Is Daniel Moyer. I'm a sales support trainer here at SimpliPhi Power. Also on the line with me is Matt Walker. He's our IQ coordinator. So welcome everyone. Thank you for joining us, and let's go ahead and get started. So what I got today for you is our IQ Installer Battery 101 training. This is going to be kind of an overview of SimpliPhi Power, its history, its products, the chemistry we use. We're even going to jump into installation, financial considerations, and finally, we're going to wrap up with a plug for the IQ Installer program. Starting with history, SimpliPhi Power was originally founded in 2010 as OES Energy. And back then, really, the lithium-ion batteries were just starting to come onto the market. And we were one of the first companies really to hit the market with the lithium iron phosphate chemistry, which is inherently safer than a lot of the cobalt-based chemistries that were coming online at that time. And the cobalt chemistries were making lots of news for being unsafe, for going into thermal runaway. So we really were founded on creating a safer chemistry, a safer profile battery. 2011, 2012, we had an opportunity to be proven with the military. At that time, the Department of Defense was using a lot of diesel generators and lead acid batteries in some of their deployments. We approached them at first. Really, the military didn't want to even consider lithium-ion batteries, but we showed them that we had a safer profile. They were able to put us through some testing, and ultimately they liked what they saw. And it was a big win for the military, a big win for SimpliPhi Power. And we did ultimately deploy. 2013, 2014, we began to expand our product line. And that's when we introduced what I would say is our best-selling battery to this date, which was our PHI battery. 2015, 2016, we relaunched, rebranded as SimpliPhi Power. And we started to introduce, again, new products, this time the Access energy storage system that you see there in the picture. 2017 to 2020, and really even up to today, we've been ramping up our manufacturing. It's a new research and development facility. We introduced the Amplify battery, which is just like the standard PHI battery, but has some internal battery management system, a closed loop communication battery management system. So as I mentioned, we were really founded to be a safer alternative to a lot of the batteries on the market, to give your customers a peace of mind. And really, you don't have to believe my word for it that we're a safer battery. Why? Because we went to the UL, and the UL has provided listings for our batteries. So I'll run through these really quickly. It's 1642 UL is on the cell level. So these are the actual little cells inside a battery module. We have that listed. We have UL 1973 on the battery module level, so the battery itself, and 9540 on the system level. We also have obtained a 9540A test protocol. So this isn't a certification. What this was is they actually took one of our energy storage systems, UL did, or third-party testing did, and put it inside a test chamber. And then inside one of the battery modules, they wrapped one of the battery cells in a heating wrap, essentially, and forced one of the cells into thermal runaway. And it really took a lot of energy to do that. Once it did go into thermal runaway, they watched what happens, and then they issued a test results. And I could spend this whole hour just talking about the 9540A testing, but essentially what happened is it did go into thermal runaway. It spread a little bit to adjacent cells, but it didn't start a self-propagating fire inside the battery. The battery didn't spread to other batteries. The batteries didn't spread outside the cabinet into this test chamber, which would be, the homeowner's garage. So it was a nice proof in the pudding to show that how safe one of these systems can be, even when you do force it into thermal runaway. So UL certifications are great to prove that we're safe, but it's also necessary more recently when a lot of jurisdictions, a lot of AHJs, and a lot of inspectors are starting to ask for some of these UL listings at the time of inspection. So the last thing you want to do is be there at the day when your inspector's on site and they start asking about these UL listings. You want to be sure you have them. Of course, you always want to check with them beforehand to know what's required. Maybe you're not even having it inspected, maybe you're off grid. for insurance purposes, what if you have an incident and the insurance adjuster's coming around to look for these UL listings? I would recommend you always have a UL listing on any energy storage system you're going to use at a home. As I mentioned, SimpliPhi Power is known for safe. We use non-toxic, non-hazardous. That's mainly due to the cobalt-free chemistry, which doesn't have that risk of thermal runaway with a self-propagating fire. Talked about, we have those UL listings, but we also have Department of Transportation 3480 and 38.3 listings, which allows us to ship these batteries LTL and also air cargo ship these batteries. For those of you in California, we are SGIP approved. So you could potentially get a lot of money back for a customer if they have a well pump or a medical device on some of these energy storage systems. Because we source LFP, we're able to avoid some child labor in the supply chain. That's mainly due to being cobalt free. We're proven, and that's one thing I want to really hit on, is that there's a lot of new battery companies on the market. One thing SimpliPhi Power is known for is its decade of experience and growth. We still have some of those original OES energy batteries out there outliving their warranty. So we have a lot of experience building these batteries. We're deployed all around the world, over 100 megawatt hours installed. I talked about us already being tested by the Marine Corps and also the Army. One thing that I really love about SimpliPhi Power working for them is that we have a business model that demonstrates social impact and profitability can coexist. This is the so-called triple bottom line: people, planet, and profits. So we do give back. We give back 1% of our gross to projects around the world, and you can check them out on our website and see some of those projects in the field. Again, I talked about we have airship. One thing I'm also proud to say about SimpliPhi Power is that we actually make these batteries in the United States. We make them in Southern California, in Ventura County, in Oxnard, and I've been there. I've seen the production line, so it's really exciting to know that we're making them here. We're simple technology. We were really founded on making a battery that makes it simple for the homeowner, makes it simple for you, the installer. The batteries, the PHI 3.8 is a great drop-in lead acid replacement. As long as some of that older equipment can meet some of those custom set points we're looking for, you can go ahead and use our batteries, give their customers that resilience, that energy security that they're looking for. So originally, the problem was that we were founded on is unsafe chemistries. Some of the new problems on the market that energy storage systems can solve, and I would argue any energy storage system can solve, is one, escalating energy costs. A lot of utilities are starting to raise our rates, not just across our tiered rates, but also implementing time of use rates and surge pricings. Well, we can program energy storage systems to discharge during those expensive times and use grid power when it's cheap, saving your customers money. Another thing customers are really concerned about, and the problem is failing infrastructure. You know, the grid really is in a state of decline. It hasn't been kept up the way it should. It's susceptible to weather events. So by giving an energy storage system to your customer, you're giving them that energy security from the power's out in the neighborhood, their power stays on. A final thing a lot of customers and anybody should be concerned about is the environment, decarbonization. A lot of utilities, a lot of jurisdictions, a lot of governments are setting these clean energy goals. We really need a way to meet those goals. Wind, solar, raw renewables are an intermittent power source, so by having an energy storage system, we can help store that power when it's generated and use it when we need it. I kind of got into it a little about lithium iron phosphate is the chemistry we use. That being said, you know, there are a lot of cobalt-based chemistries on the market, and certain applications, cobalt may be the best solution, right? If we're talking about our cell phones, we're talking about our laptops. But when it comes to our homes, to our businesses, to our castles, we aren't really caring about that energy dense cobalt chemistries. What we really want is a safer chemistry, and that's what LFP, lithium iron phosphate, is going to provide us. There's no danger of a thermal runaway or a fire, no toxic elements. You can recycle these, you just don't want to take them to the landfill. We're able to avoid some abusive mining practices by being that cobalt-free chemistry. Not needing ventilation, cooling equipment, or safety monitoring equipment is really an advantage. And here's why, is because if you're relying on a piece of a cooling equipment to keep the battery in spec and that piece of cooling equipment fails, well, the battery fails. So these are other modes of failure that cause systems to fail. And so if we can remove those, we're increasing the reliability of the system. I'll go into it here in a minute, but we're able to work in some really extreme high temperature, low temperature environments. Talked about chemistry. Chemistry isn't the whole reason why our batteries are safe. It also has to do with the way we construct the batteries, the way we put things in the battery, the way we do our battery management systems, our intellectual property that we've used to design these batteries. One thing is that the form factor matters. Inside these batteries, we use cylindrical form factors. Think AA, think AAA batteries. These cylindrical form factors are safer because they're encased in a metal case. Also, they're relatively hard to short out because the negative and positive are at opposite ends of the batteries. Pouch cells, which are found in some of our competitors in laptops, can be prone to puncture. They can swell. Prismatic cells, nothing wrong with those. It's just that they tend to be very bulky. So we found using that chemistry and this form factor, the way we construct the battery gives us this safe, reliable product for your customers, for your homeowners. When it comes to the warranty, we offer a 10-year warranty, unlimited cycles. Some of our competitors will say, a certain amount of megawatt hour throughput or a certain number of cycles at a certain depth of discharge over a certain amount of time. We want to keep it simple. 100% depth of discharge. You can cycle it all the way down, unlimited cycles for 10 years. At the end of that 10 years, you're still going to be guaranteed 80% of your battery's capacity after that 10 years of usable battery capacity. That being said, in a lot of situations, we really would recommend an 80% depth of discharge. That's going to give your homeowner, your business owner, the most life of the battery after the 10-year warranty period. When it comes to temperatures, any lithium-ion chemistry really doesn't want to be charged below freezing. So for charging temperatures, our window is 32 degrees Fahrenheit to 120 degrees Fahrenheit. The operating temperature, which is discharge or at idle, is -4 to 140. Now, if you're in a situation where you're going to be colder than 32 degrees Fahrenheit and you're going to be wanting to charge these batteries, there is other ways to do that. And we have other trainings where we talk about how we can mitigate these cold temperatures. Check out our pre-recorded trainings on the YouTube channel. Keep an eye out for upcoming trainings on these. The ways where we can mitigate cold temperatures are heating pads, insulated battery cabinets. We start to talk about understanding the temperature gradients between inside and outside the battery cabinet. There's no need for a coolant, HVAC, and ventilation. So there's no need for that vent fan to get rid of that hydrogen. Again, these are all other modes of failure that we don't need to worry about in our battery system. All SimpliPhi batteries come with an internal battery management system, a BMS. The standard PHI batteries have an internal only battery management system. It's really there to provide high level protections, overcurrent protections, short circuit protection, charge and discharge protection, but it's mainly there for cell balancing. The SimpliPhi battery that I talked about has closed loop communications. So that's a battery that has the capability of transmitting data, transmitting set points to certain equipment. We have a third type of battery management system. It's called a stack controller, and that's used in our high voltage line. All of the batteries also have a built-in breaker that you can see here. And this gives an extra level of overcurrent protection. But it also is an added level of safety when it comes to installing the battery. You can turn the battery off essentially, make all of your connections so you're not seeing any arcing on the battery wires. You're not worried about shorting out the battery terminals with your wrench, with your torque wrench, I hope, because we want to torque these down properly. So it's a nice feature to be able to turn the battery off and turn it back on, as well as give that overcurrent protection. One thing to keep in mind about our batteries is that we have a C/2 rating. So a C rate is the rate at which a battery can be charged or discharged relative to its maximum capacity. So with the SimpliPhi Power 3.8 battery at 48 volts, it's a 75 amp hour battery. That means you can charge or discharge that battery at 37.5 amps continuously at a 48 volt rate. So what this means is that you can charge and discharge this battery really rapidly, especially compared to lead acid batteries. Lead acid batteries, remember back in the day, they're more at a C/20, a C/10. And if you're really pushing a lead acid battery, you're at like a C/5. So what this means is, imagine you have a situation where you need to charge the battery quickly. You got a generator. You can run that generator at full tilt, charge those batteries up, shut the generator off. Maybe you have a very short solar window where you only have solar during a small time during the day. Well, make that a big array, pump a lot of power into those batteries. Then when the sun's down, you know that you've got in that fast charge rate. You can also discharge them relatively fast, so you're able to provide some of those high power loads. As you add batteries, that rate holds true. So it's going to add, as you add these little building blocks up, it's going to scale up in power and energy capacity. We're able to scale our batteries up. What that means is that you can have no limit to the number of batteries you can put in parallel. You can scale these batteries up to make the system size that you need. There's no communication lines to worry about. And as I mentioned, you're scaling up in both energy storage and power throughput. Expandability. This is a great one. You can actually come back to an existing battery bank and add a battery to the system. A lot of people ask me, they say, hey, Dan, how long can I add a battery to a system after it's already been installed? I'd say the safe answer is 2 to 3 years after that. Any further than that, you're going to start to see some imbalances in the system. You want to be sure to always make sure that any of the new batteries that you're adding to the system has a voltage within 1 volt on 48 volts of the old batteries. That way you're not going to see a lot of voltage or a lot of current flowing between batteries if they don't have a close voltage. Another thing to keep in mind is that, say you have a 2-year-old system, these batteries have a 10-year warranty. If you add new batteries to the system, the warranty of the new battery reverts to the oldest warranty in the battery in the system. So what I'm trying to say here is, you have 2-year-old batteries, you put some new batteries in there, effectively the new batteries are going to only have an 8-year warranty. But it's still a great advantage. You got a homeowner that maybe can't afford a full system at the beginning. Well, get them started, get a system up and running, let them know that you can add batteries to the system later. Maybe it's a homeowner or a business owner that's had some needs. They started to grow. They added some family members. Well, you can come back and add to a system. Here's a couple pictures of what it looks like on the left here. This is what it looks like to scale up a system. That's 80 of our batteries, 300 kilowatt hours. I really like that system just because of the look of those bus bars. This is a really nice custom bus bar that they did here. This is at an airport hangar in Hawaii. Picture on the right is what it looked like to come back to a home. They had 8 batteries. We were able to add 8 more batteries. We used that existing combiner box. That SMA Sunny Island there is still existing. Really, all we had to do is change a little of the set points, and you're off to the races. One thing I really like about lithium-ion batteries and sealed batteries of any type is that they're self-contained and they're stable. They're not going to vent or release gases. You don't need to do any work over time. So When you sell a system, you don't need to set up some sort of scheduled maintenance with the homeowner, or the homeowner might say, hey, don't worry about it, Dan, I'll water my batteries. I don't need to set up a maintenance schedule. Inevitably, they call you a couple years down the road. They didn't water their batteries. The whole system, the whole battery bank is fried. So by not needing to worry about maintenance, you can spend your time doing new installs, not coming back and having to maintain these batteries. You're not going to have that vent fan because you're not releasing any gases. The LFP chemistry specifically to lithium-ion batteries holds their charge very well. They have a very low self-discharge rate, 1% per month. So what does that mean? That means that if you get one of these batteries charged up pretty good to a high state of charge, you can come back like a year later and still have that backup power ready to go. You're not going to need to worry about keeping that battery on some sort of float charge throughout that year. Here's what it looks like when you do replace a lead acid battery bank. See that picture on the left? Those look like some Trojan L16s. I mean, what a mess. All those wires, those temperature compensation sensors there. Picture on the right is what we replaced it with. And the picture on the right has just as much energy capacity and just as much power throughput as the picture on the left. So really able to clean it up and give that business owner, give that homeowner a nice clean system that we're not having to worry about maintaining. So I'm going to jump into some products before we start installation. Really, this is our best seller. It has been, this is the PHI 3.8 kilowatt hour battery, 151 amp hours at 24 volts, 75 amp hours at 48 volts. And I want to take a moment here to say that you never want to run our batteries in series, always in parallel. So if you got a 48 volt system, buy 48 volt batteries. You never want to buy our 24 volt batteries and run them in series. So again, simple parallel connections. We can scale up to the size system we need. They make a great drop-in lead acid replacement. Just gotta disable that equalization stage. Like I mentioned, 24 or 48 volts. It has that integrated battery management system. Really, that's the last line of defense. This battery management system is not an excuse for a poorly programmed or a poorly sized system. So you want to make sure you get that all dialed in, because it's going to protect the battery. But if you repeatedly go out of nominal conditions, it's not going to like that. We got that integrated circuit breaker in there. We do have a 12 volt option. So this is the PHI 1.4. It's essentially the same as the 3.8, but half the size, and it can come in 12 volt options. So we find these great for mobile applications. It's small, it's lightweight, it's able to fit into tighter spots. It still has that integrated battery management system in that breaker. You might have seen these with Anderson power pole connectors before, but we've recently upgraded these to the same 3/8 inch terminals that the standard 3.8 PHI battery has. A couple of our energy storage systems. The first one I want to talk about is our Express energy storage system. This is essentially a mobile cart that's in a weatherproof NEMA 3R enclosure. It has a couple batteries in there, a nice inverter, a charge controller. So think apartments, think places where you can't hardwire something. This could be hardwired theoretically, but it's really not meant to be. It has a DC inlet right here, so you can just run some solar arrays. It's going to go right into that charge controller, keep these batteries charged up. You don't need solar though, because you have an AC inlet right into this Magnum. It's going to charge up those batteries, keep them ready to go when you need it. When you do need the power, you have 4 outlets to charge, to power items. You got a couple of USB ports. One thing I always thought about this is service changes. When you're doing a service upgrade at a home, the utility companies cut power and you're upgrading maybe from 100 to 200 amp service. Roll this thing out to the job site. Maybe you have a couple older homeowners inside. They want to watch TV. They want to be able to make lunch. Run a couple extension cords in. Then you can have a couple extra outlets to charge your tools, run a drill if you need to. Our more popular energy storage system and a permanent install is our Access energy storage system. We have a couple different inverter options, and you can put some batteries down at the bottom of the cabinet. It can be AC coupled or DC coupled. So if you got new PV, that's great. If you got an existing inverter on site, well, go ahead and AC couple it up. No maintenance, and we have that 9540A test protocol on this, and the 9540 UL listing as well, so you know you're getting something safe for that homeowner, that business owner. We also have battery cabinets. Essentially, the Boss 12 is that exact same energy storage cabinet, except with the inverter on top, it has batteries on top. The Boss 6 there, and I want to take a moment to tell you, you don't have to fill these up, right? You're seeing these with as many batteries as they can handle. That Boss 6, you can put 4 batteries in there if you want. It still makes a great solution. If you want to do something outdoor rated, you don't want to put it in the garage, and keep it out of the homeowner's space. We also offer a high voltage solution. I'm not going to go too much into this. This isn't my expertise. If you are interested in high voltage, I'll connect you with one of our sales application engineers. They can design some custom needs for you, but essentially these are containerized solutions for microgrids. You know, anything that when you start talking 480 volts, 3-phase, this is what you want to start looking at. It has that external battery management system, which is that stack controller. And we can scale these up just like we can with the building blocks of the PHI 3.8 and the 1.4. And they have all the communication capabilities that you're going to be looking for a larger solution like this. Last product I want to touch on really quickly is the SimpliPhi 3.8. So this is just like the standard PHI 3.8 battery, but this one has closed loop communication capabilities. And you know it does because you can see up top here the communication ports. The 2 ports on the left go between batteries. The port on the right is the home run, which goes up to the equipment. Right now we have integrations with SolarArc and SMA, Sunny Island. We're working on more, but that closed loop communications doesn't require any external cards like some of our competitors. It has a max discharge of 100 amps at 10 minutes. Just to go back, the PHI 3.8 has 80 amps at 10 minutes. So this one has a slightly higher discharge, max discharge. So if you got well pumps, you got a lot of motors to start, it might be a situation where you want to look at the SimpliPhi. It's the same size, so it's going to fit into the same wall brackets and battery cabinets as the standard PHI does. This one has built-in temperature protection. So back to some of these extreme temperature environments, if you know you're going to be in some of these cold environments, think about the SimpliPhi, because it's going to tell the equipment, hey, it's starting to get cold. Let's ramp down some of this charge rate. Hey, it's too cold. Stop charging me. This has built-in thermistors inside the battery so that it knows what its internal temperature is and can offer that higher level of protection. We're limited to 75 batteries on the SimpliPhi, which is still a huge system just because of the limitations on the communication runs. And those communications allow a much higher level protection, like I mentioned, but also much higher readings of its stated charge, its voltage, and its charge and discharge, because the battery internally is telling the equipment that, not the equipment trying to figure out what the battery is doing. One thing I want to jump into, and I always like to talk about, is the levelized cost of energy. Essentially, what's the cost of an energy storage system, not the price. So when we're sitting at a kitchen table with a Mr. and Mrs. homeowner, and we got a couple quotes sitting there on the kitchen table, ultimately one's going to be more expensive than the other. It's our jobs as energy consultants to help the homeowner look past what's the upfront cost, but what's the cost of the system over its life? What's the cost for every kilowatt hour I can put into that battery and take out of that battery over the life of its system? So I like using math at the kitchen table, because math takes you out of that salesperson role and puts you more into that energy consultant role. So here's the equation, and we'll go and do the math equation here in a second, but essentially you take the price of the battery over the capacity by the cycles that it's warranted for, the efficiency over the depth of discharge you plan to run the battery at, and that will give you the cost of every kilowatt hour you can put in and get out of the system. And just that alone is, I know that our batteries are going to be ahead of lead acid batteries and a lot ahead of a lot of our other competition. That doesn't even account for ancillary costs, like how much more space is this big battery bank going to take? You know, how much does it cost to ship some heavy lead acid batteries to you? Do I need special equipment to install the batteries? You know, what's it going to cost when I hurt my back moving some of this heavy equipment into the site? You know, not needing cooling, ventilation, construction systems, you know, to support that extra weight. So let's jump in. We don't need to do the math because we have on our website a calculator that does the price for us. And you can find this on the SimpliPhi Power website. And everyone's going to get a copy of this presentation, so you'll have this link as well. So let's go ahead and choose a battery. Let's go ahead and choose the PHI 3.8. That's one of our best sellers. I found a price online. You may have a different price if you go to your dealer. You know, this is just a price I found that I'm going to pop in here. Let's go ahead and select 80 cents or 80% depth of discharge. So here down in the purple is what it's 9 cents cost per kilowatt hour to put in and get out of that battery over its life. Down here, so you do this at the kitchen table, you know, bring the laptop, bring the tablet, and then go ahead and type in some of these other chemistries, some of these other lithium-ion battery competitions, and show that homeowner the advantages of that life of the system cost, not just what the upfront price is. When it comes to sizing, there's two things, right? We need to size for the capacity of the energy storage system and also the power, the ability for it to provide the power needed to power the loads. First, on the usable storage or the capacity, let's figure out what we're gonna, our optimal depth of discharge we're gonna spec for. You can cycle it down to 100%. You're gonna use all 3.8 kilowatt hours of that battery. That's fine, we warranty for that. Really what I'd wanna see though, for most situations, is an 80% depth of discharge. You're gonna get a lot more cycles of that battery. You're gonna give that battery a lot more life after that warranty period. So if you're in an off-grid home, maybe a zero energy home where you're cycling that battery daily and you want to give that homeowner, that business owner, a lot of cycles, let's go with 80%. But maybe you're in a situation where you're really not cycling that battery every day, a battery backup, or maybe you're just shaving peak demands. Go ahead and size for a 90% or 100% depth of discharge. You don't really need that extra capacity. You're not cycling it every day, so it's more acceptable to do a 90%, 100% depth of discharge on those situations. When it comes to sizing for power, one thing I really want to be careful to mention is, and really spend a moment here to talk about, is the batteries have a C/2 continuous charge or discharge rating. So what this means is that imagine you got this 8,000 watt radiant sitting here. You want to be sure that the batteries are twice the size of the inverter's output capability. So if you got a radiant 8,000, you want to see 16,000 watt hours of batteries, or 16 kilowatt hours of batteries, so that at no moment will that radiant ever try to pull more power out of those batteries than they're able to handle continuously. I talked a little bit about that SimpliPhi battery. With the SimpliPhi battery, we let you get around that a little bit because we know the SimpliPhi battery is talking to the inverter. It will actually tell the inverter, look, there's only 2 of us here. There's only 3 of us here. Don't pull or push more power than what us 2 or us 3 can handle. So when you're sizing for SimpliPhi, got a little more leeway. When you're sizing for the standard PHI batteries, I really want to see that C/2 rating. With charge controllers, you know, we see all these Outback charge controllers here. That's not such a big hard fast rule because we know we can program those charge controllers to limit their charging amps. You can't really program an inverter not to work at its full capacity. So again, C/2 rating, I just want to make sure that's clear to everyone. If it's not clear, we have some tools online to help you size the system. This first link up here is just a simple battery bank sizing estimator. It's going to ask you for how much power is the home consuming, and you know, energy consuming per day, how many days of autonomy you want to be looking at. It's going to spit out a number. That second calculator you see there in the middle, that one it's much more in-depth. It's going to ask you, well, what equipment are you using? Are you AC coupling? Are you DC coupling? And that's going to give you a more accurate number to make sure you're not over discharging these batteries or overcharging them as well. The last tool you see there is just a simple lead acid battery bank replacement calculator. You come out to a site, you tell me how many lead acid batteries you got. It's going to tell you how many SimpliPhi power batteries you need to replace that. We want to make it simple, and we got some tools for you to do that. I'm going to jump briefly into installation, just kind of sail through this. If you're interested in installation more in depth, we have other videos that really jump into this and go deeper. One thing is, and everybody's guilty of it, is please read the manuals. We have spent a lot of time making good manual spec sheets. If anything, read the integration guides. We spent a lot of time working on integration guides, which says that if you got Outback, you got Schneider, we have created an integration guide for that specific equipment. It's going to walk you through how to program that piece of equipment in the order in which the equipment's asking for that programming. So, you know, print those out, have them in the van, have them in the truck, so you're not out there in the field and you're not getting good internet. I'm going to quickly show everyone where to find that on our website. It's under the product documentation tab. And here you can find the spec sheets, the warranties, the installations, and finally here are the integration guides. So again, we have a lot of the major manufacturers here, and keep an eye out for any new ones that may come along. If you have a piece of equipment that's not on that list, call us, call our tech support. We got a great team that can help you out. When it comes to installation, there's no clearance requirements required. You can put these batteries right up against each other. You can use some of our wall brackets that you see here in the picture. I already mentioned those Boss cabinets, Boss 12, Boss 6. I've seen a lot of really great custom boxes built. So we really leave it up to you. You can orient the batteries in you can put them on the side, on their face. Really, the only orientation we don't want to see is with them upside down, with the battery terminals facing down. And we don't want to see them stacked on top of each other because the weight can start to build up a lot on that. When it comes to wiring these batteries, it's a little bit different than our good old lead acid battery days, right? Again, we're always going to do parallel here, but if we did parallel, you know, we'd go positive, 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 and then a home run to the equipment. We don't want to see that. What we want to see is conductors of the same length, of the same gauge, going to a common terminal connection point, then feeding in a much thicker conductor, a much thicker gauge up to the equipment. What this is going to do is prevent batteries from working harder than others and avoid any voltage drops in the lines. You can use battery combiners. You know, some equipment has the ability to combine some of those battery home runs inside the inverter cabinet, but there's lots of different bus bars, terminal blocks, ways to make these batteries combine before going into the piece of equipment. And there's even custom ones out there. We sell those bus bars as well, and I'll show you that here in a picture. You can see it here in our Boss 12 cabinets. These are our BB3 BB-3 bus bars that then go to a terminal block that then go to a combiner box. If you didn't have the second, BOS 12 here, you could run directly into the Solarc from that BOS 12. Really quickly, here's a picture of what it looks like to see a system. We got our Solarc. We have our Tigo TS4 rapid shutdowns. Here's our Tigo transmitter sending that keep alive signal. Here's our critical loads panel. Here's our non-backed up loads panel and grid feeding into the Solarc, so we can backfeed to the grid. One thing I want to take a moment to point out is the Solarc has really taken a lot of strides when it comes to rapid shutdown capabilities. This Solarc actually has a 12-volt power supply that's powering that Tigo transmitter, and the Solarc has the ability to do a rapid shutdown button. So you push that shutdown button, it's going to kill 12 volts going to the Tigo transmitter, which is going to kill the panels. It's going to stop power flowing to and from the batteries and put it into a safe mode. A lot of fire departments, a lot of inspectors, AHJs are looking for this rapid shutdown compliance, and Solarc is making it easy on us. Lastly, to finish up on some of the installation suggestions is your torque wrench. Really, the last thing you want to be is out there at the last day of the job or last day, you're making those battery connections. Please go out to the van, go out to the truck, get your torque wrench. Hopefully it's been recently recalibrated. We want to see 160 inch-pounds on those battery terminals. The last thing I want to see is one of your technicians out there with an impact driver, going to town on one of these battery lugs and it's snapping off. Maybe your torque wrench should be insulated and be an insulated tool. But remember, the batteries have a built-in breaker, so you can turn that breaker off and make those battery leads go dead, so you're not worried about arcing and getting a big pop. I'm gonna finish off on the access before we talk a little bit about the IQ program. I talked about it a little bit earlier. This energy storage system with that 9540 UL listing, it comes pre-wired, pre-programmed. Make sure you check those programming before you turn it on, though, just in case something happened in shipping. The batteries come separate, so you are going to have to install those batteries and get your torque wrench out and make those final battery connections. But it has everything you need inside. Here's a picture with that Solarc with those SimpliPhi batteries at the bottom. They're SimpliPhi again because we can see the COM ports. That Solarc has built-in maximum power point trackers. We can program that to do self-consumption, time of use. It also has that rapid shutdown capability that a lot of people are looking for. One thing that really makes a homeowner happy is apps, right? In an old off-grid days, people were used to going to the equipment, looking at their volts, their amps, this and that. Nowadays, people want an app. They want it on their phone. They want it on their tablet. Solarc has got a great product out there. Obviously, you do need internet for the Solarc to talk to, but you're going to be able to see real-time monitoring, historic monitoring, which is great for us in tech support to come back around and help somebody out. There's two levels of the app. One's for the installer, where we could go back and make changes to the set points, which is great. Say you commissioned a system, you're back at the office, you realize you didn't do something right, go into the app, change some of those set points, adjust that low voltage battery cutoff, maybe if you want to play with that a little. The end user doesn't get that ability, so they can't mess with their system, but they still get what they want to see, which is, what's my battery capacity at? What am I using? Am I backfeeding the grid? Solarc has got a great product with that. Lastly, everyone, I want to just talk a little bit about our SimpliPhi Elite IQ Installer program. If you're installing our batteries and you haven't already signed up, I please encourage you to do this. Essentially, what we're going to do is we're going to put you on our website. If anyone comes to our websites, to our where to buy map, and somebody in your area finds you will pop up. They will, drive business to you. We're also offering some money back, right? So we're offering $25 cash back through every battery installed, but we're also doing a photo contest. I love seeing photos. I love seeing photos of equipment, but what I love even more is seeing pictures of homeowners standing in front of the equipment. I love seeing pictures of you, the installer, in front of the equipment. It tells a story. It makes it so much more engaging when you see people in the photo. So send us your photos. We'll enter them. $250 is what you can win. If you don't win 1 month, we're going to roll that entry over so you can continue to have a chance to win. That's the link. 10 minutes at most to apply. And if you have trouble with it, email me. I can help walk you through it as well. Well, thanks everyone for joining us today. We do have a little bit of time left for Q&A. So if you have any questions, now is a great time to put them into the Q&A bar. If you need NABCEP credits, if you want your continuing education credits, please email training@simpliphipower.com. I need your first name and your last name spelled out for us so that we know who to put, what to put on your certificate. Matt is with us. Matt Walker, my coworker, is with us today. So why don't we go ahead and jump into the Q&A and see what we got. Looks like Matt has already answered a couple of the questions, but we can kind of go through that.
Yep, awesome.
Yeah.
So I see, Karina, you're looking for some more information about where to find our recorded videos on combating cold temperatures. Go ahead and email us at training@simpliphipower.com and we can send you direct links to the recordings. They're also on our YouTube channel.
Thank you, Matt. John, you say, is the inverter bidirectional? Can the source and supply be the same panel versus a sub panel? So a solar has actually two AC inputs. So you can use the grid input or the gen input to have a panel. So you can have a separate AC input. It is bidirectional, so you can pull power from the grid to charge batteries, to power loads, to do what you need to do, but you can also push power back out onto the to the grid. Can the batteries be connected in series? Steve asked this. No, we don't want to see the batteries ever connected in series, always in parallel.
Joe, I wanted to point out to our batteries use the Cat5 cabling for communication on those amplify. And then I wanted to point out to Ray that the email for NABCEP credits is on the screen right now, training@simpliphipower.com.
Yeah, thank you, Matt. Frank, you're asking about how to calculate the cost of a kilowatt hour through throughput. Email us. I can help you, break apart some of those numbers. Some of that math is shown on there on the website, and to kind of walk you through that. Michael, you're saying, how is the solar array and generator coupled? So the solar itself can tell the generator when to turn on, when to shut off. If the solar array isn't providing enough power to keep those batteries charged, it can couple that in. That's specific to the solar. There's lots of other ways to do that. We can start talking about the transfer switches and doing whole home backups as well. Let's see.
For calculating the cost of a kilowatt hour, yeah, we'll get you some more info on that, but ultimately it's just the number of kilowatt hours the battery bank can provide over its entire lifespan divided by the total cost of the system.
Thank you, Matt. Yeah. Brian's asking about future Bluetooth Wi-Fi connectivity capabilities. So, you know, a lot of the equipment is moving that direction. Our batteries, you know, transmit that data to a lot of that compatible equipment. And then it's the inverter's job, it's the charge controller's job to transmit that stuff. A lot of them do have Bluetooth at this point, and a lot of them have Wi-Fi as well. Almost all of them have Wi-Fi. Steve, you're asking, do you have a 400-volt battery system? That would be our high voltage systems. So if that's something you're interested in, email training at simpliphipower.com, and I'll connect you up with one of our sales applications engineers on the high voltage side, and we can go ahead and do that. Gregory is asking, is there any integration with my Briggs & Stratton home standby generator? Yes, some of the Briggs have a 2-wire start, and the Solarc can work with 2-wire start batteries. Some of them have a 4-wire start, but there is ways to get that to work. There's a little adapter, a little accessory that's needed for that. Matt, do we see any other questions?
Yeah, I know Karina wanted some more info on SMA communications with SimpliPhi. So you would be monitoring that through the SMA's portal online. So yes, to that question. And secondly, to get you more info, just email us and we can send you our integration guide that shows how to program it and any other info you need.
Thanks, Matt. Sean is asking, in the event of a grid outage with an AC coupled inverter, can the battery system create frequency so the inverter will see grid voltage and continue to produce power from the PV and charge batteries? Yes. So essentially, the inverter inside, so your hybrid inverter will create essentially a fake grid that will allow the microinverters, maybe some N-phase inverters or whatever else you got, to come back alive, and continue to producing power. One thing I do want to mention is that when you do have AC coupled solar, we kind of want to see that C/2 rating. So say you have 8,000 watt of solar, well, we'd want to see 16 kilowatts of batteries, so that never will the solar push more power into the batteries than they can handle. When you AC couple something, you're relying on frequency shifting to curtail that solar production, and that doesn't necessarily happen as fast as it should when you say you're using a charge controller. So keep that in mind when you're going forward with any AC coupled systems.
Yeah, great point. Also, John, to answer your question, it sounds like your solar is AC coupled and applied right to your main panel. This is usually referred to as grid tied solar. So in order to retrofit this such that your system would keep the solar running in an outage, you would need the inverter to be between the solar and the grid. So it can send a grid signal to the solar, keeping it online, and completely disconnect from the grid for safety reasons.
Thanks, Matt. I see a question, what are the range of inverter brands compatible with the SimpliPhi battery? Really, we've made it compatible with a lot. As long as that inverter can meet the set points that we're looking for in our integration guides, in our manuals, you can use it. Some inverters don't have the ability to have custom set points. So really, if that inverter is able to be custom set points, we can go ahead and meet that. You can use that. So, you know, a lot of times the low voltage battery disconnect is one that you're going to want to see. Sometimes the equipment, older equipment, isn't able to get the low voltage battery disconnect high enough to where we want to be able to protect our batteries. So that's something to keep in mind. A lot of these older inverters are meant for lead acid batteries that could discharge lower than, say, 24 volts. The highest you could set it is 23. So if you have any questions on you know, compatibility, just reach out to tech support. Tech support at simplifypower.com and we can help you out. Let's see, I think that was it for everyone.
Did we cover the range of inverter brands compatible? I was just going to say that there's a wide range of inverters that are compatible.
Yeah.
So if you have any questions, we'd be happy to address those. Sean, make sure to email us if you need NABCEP credits. Steve, we do have a 400-volt battery system, but this is not residential. It's really commercial. And Michael, the solar array and generator are both coupled to the inverter. The battery-based inverter is going to be the buffer between the battery and those items.
Thanks, Matt.
I think that's everything.
Yeah, and anyone who's, take a look at our YouTube channel. I'm going to plug it really quick. Our YouTube channel has a lot of pre-recorded videos that talk about temperatures, talk about installation, talk about all of these topics more in depth. And keep an eye out on our training calendar for upcoming ones. Thank you, Matt, for joining us, and thank you everyone who's with us today. We look forward to working with you all.